Among the oldest structures on our planet, castles constitute a fascinating part of our history. They inspire the imagination with their strong walls and high towers, often perched on hills or cliff faces. They also provide an interesting challenge from a computer vision perspective. They are large structures which can be viewed from many angles. They are subject to many kinds of occlusion, and they have recognizable features at multiple scales. Our main contribution, the castle's dataset, features nearly 773,000 images, covering 2,412 castles from 93 countries or locations all around the world.
Our work aligns closely with three areas of computer vision: fine-grained and instance recognition, landmark recognition, and image geolocalization. Fine-grained visual categorization is characterized by low interclass and high intraclass variation, with subjects such as birds, dogs, and cars. Instance recognition is the more extreme case where each class is a unique object. Our dataset consists of castle instances, but has some aspects which are similar to fine-grained datasets. Place or landmark datasets usually focus on the instance recognition problem, and typically leverage crowdsourced data from around the globe. Our dataset is also global, but focuses on only one type of landmark, castles. Our dataset can also be used for image geolocalization experiments, which seek to assign physical coordinate locations based on image data alone. This problem was first proposed by the authors of Im2GPS.
To create the dataset, we leveraged metadata and images from Google Maps. We began by searching Google Maps for castle names and locations. We were able to find several thousand candidate landmarks, which we then sifted to remove any that weren't actually castles or which were in a state of ruin. In addition to the names and locations, we crawled the web to obtain approximate construction dates or eras for each castle. We obtained images by downloading user-uploaded photos linked to each Google Maps location that we included in our final set. This yielded an initial pool of over 1.6 million images. Unlike other landmark datasets, we wanted the castle's dataset to focus on external architecture. The images shown here are examples of those removed because they captured interior scenes, views of scenery or grounds, paintings or models of castles, or castles in disrepair. Due to the large volume of images gathered, we relied on a semi-automated procedure to remove these unwanted images, iteratively labeling images by hand and training binary classifiers to remove these irrelevant images.
We conducted several experiments with the castle's dataset, including instance recognition, image retrieval, country location prediction, and geolocalization. Experiments were repeated on multiple splits of the data, and aggregate results are reported. See the paper for additional details.
In our instance recognition experiments, we classified each image according to the castle it depicts. Our results using a ResNet 50 are shown on the right. The overall performance is quite good. We also looked at per-class performance and found that castles with fewer images tend to be misclassified more often. The results of our image retrieval experiments are summarized in this figure. We trained a ResNet 50 model using triplet loss and performed image matching on a held-out gallery consisting of 2/5 of the castle instances. This task proved quite challenging, in part due to the large gallery of over 300,000 images. For country location prediction, we trained a classifier to predict, given an image, the country that the castle belongs to. We evaluated the classifier on a held-out set of castle instances. The accuracy by country varies, ranging from 96% for Japan, which has very distinctive castles, to below 10% for some countries, Austria and Romania, for example. We also conducted a blind geolocalization experiment. Given a held-out query image, we find the most visually similar castles and regress an estimated location based on their locations, weighted by frequency. For our baseline ResNet 50 model, the median error in the estimated location was just 595 kilometers, which equates to less than 5.4 degrees on a great circle around the Earth. For deeper insight into the dataset, we also attempted to quantify difficulty at the image level. We used cross-validation to obtain multiple classification predictions for each image, and grouped them according to the number of correct predictions, as well as the prediction diversity. This figure shows the distribution of predictions per image. We can see that there are many images which are easy to classify, but others that are quite challenging.
In conclusion, we present the castle's dataset, a large dataset of castle images, and conduct several visual recognition experiments using it. Our experiments and analysis have focused on classification, image retrieval, and geolocalization. We anticipate, however, that the data can be used in a diverse set of applications, including local descriptor learning, correspondence and matching, multi-view reconstruction, and generative modeling. The data is publicly available, and we hope the community finds it useful.
Bye-bye, boys!
Have fun storming the castle!
Think it'll work?
It would take a miracle. Bye-bye!